This is the Amp Hour Podcast, released July 17th, 2023, episode 639. Damn, we're done.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
Who are you? It's been so long.
It's been so long.
I'm Chris Gamble of Contextual Electronics.
I don't know. Well, you're buggering off tomorrow somewhere.
I know,
aren't you?
exactly. We're going to, the summer of 2 or 3 shows of Dave and Chris.
Well,
Yeah, it's good.
This is not our main gig. It's
good,
not like...
Good to catch up with you, chap.
What's been happening?
On the Amp Hour, I guess. Some great guests recently. We did an AR show with a college grad who's doing amazing stuff. We did the CH32V003.
Yes.
I just got a reel of those parts today. Not a reel,
Oh,
sorry.
a whole reel.
A
Okay.
chunk. I got a chunk of
Right.
a reel. 150.
Okay.
Yeah. So lots
Nice.
of fun stuff. What about you, man? You been walkabout?
I've been walkabout for a couple of weeks. Yep.
Yeah. Living that good life.
No one realised, did they? No.
He planned so well.
Yes. Oh, boy.
Oh, yeah. Where'd you go? Anywhere fun?
Oh, I drove all the way out to Broken Hill. It was a road trip, which
Cool,
it's in
cool.
the outback, for those who don't know.
Yep.
It's in the middle of nowhere. It's not quite the back of Burke, but, Sorry, that's an Aussie
Yeah.
expression.
Yeah, I figured.
Anyway, outback, all the red dirt stuff, things like
Yeah.
that. So I've got a video
Cool.
I'll edit after this. I visited the world's first solar power station.
Oh, interesting.
Yeah.
Okay.
Yeah. No solar cell rubbish. This is, solar thermal.
Oh, so like reflectors up onto a
As in
tower.
a focus, as in a focus dish, and then they superheat steam in a pipe at the focal point of the dish, and it was the world's first one from 1981. So there you go.
So when you look at something like that, you like walk up to it. I mean, obviously the dishes are all focused at the focal point, right?
Yep.
It's like parabolic in that way. Can you feel heat coming off of it? I mean, I don't even know how close you can get.
It's no longer used, so they weren't pointed at the sun, and there was no sun that day anyway. Ironically, here I am filming in the highest solar insolation point in the country, and there's no sun. It's like, oops.
Yeah, that's how it goes. Yep.
Yeah, had a slate of bad weather.
Uh-huh.
So yeah. Yep.
Okay. Well, that's cool though. Yeah.
And
yeah.
but no, it only lasted for 10 years or something like that, and basically nobody does it like that anymore. Nobody does. There are some solar thermal plants around, but they're not done using the dish with the focal point of the parabolic reflector. They all are like a tower based, so they all have like a central tower, and then they have the
Interesting.
mirrors,
That's what I was
which
having in
then.
mind.
Right. Oh,
Yeah,
no. Each one is its own little individual heater. So it's actually a dish. It actually, when I was driving, I didn't even know this was there, right? We were going to this little town. I had no idea this was there. And I'm going, why? Like, this is the tiniest tin pot town in the middle of nowhere, right?
Uh-huh.
And we're going, what are these dishes? What are these satellite dishes? And I'm looking at them, and there's like, a dozen of these satellite dishes. And I'm going, what the heck is going on here? And then we get closer, and I go, they're not satellite. There's something's weird's going on here. Yeah, and I find out that, it was the world's first solar thermal plant.
Huh.
So there you go. Yeah.
And this is just heating water, not heating like salts or anything like that?
No heating water. No, that's what I was saying. The newer ones, they have like a massive tower, and they're like tens of megawatts.
Yeah, the tower. Sometimes they do. Don't they do like molten salt sometimes?
They're molten salts or something like that. Yeah, they're usually something, some sort of thermal absorbing material like that. But no, this was basically a coil of wire which you ran water through, and it just superheats it to 500 to 1,000 degrees Celsius. And
Spicy.
Yeah, superheats these, and they've got they converted a generator into a steam, so that steam can drive the thing. And
Yeah, it does sound like that would be high maintenance, I guess. Like it's basically halfway to a steam plant, right? I mean, and that's just a lot of, and then it's also got the elements being down on it, whereas like steam plants, if it's like a coal or gas, it's at least all the piping's internal.
It's
right?
all internal. It's one
like
big central thing, whereas this is 14 individual dishes. So you've got to run the water up to each dish, and then and then you've got to run it through the pivot mount because each dish is like an auto tracking thing, you know, and it's like
so then you're like weight limited too. Yeah, so and it does seem like there's a lot of like scale. You look at like a nuclear plant, it feels like the scale is probably the most important thing there. One of the most important things, just because you want to have, you know, you've already got a lot of power output, then you also want to have you have a lot of energy output from the actual nuclear material, but then you want to also like translate that into steam and all of the turbines turning and stuff like that.
Yeah. And this thing just didn't scale. There's a really detailed report, which I'll link in my video, which, you know, after 10 years of operation, they, you know, figured out was it viable and everything. And we're not talking huge amounts of power. We're talking 25 kilowatts here, right?
Oh, wow. Okay.
This is like the equivalent of like a large home solar array, like some people have. Like I know people with like 30 kilowatts, you know, 35 kilowatt. Home solar arrays, right? And this thing's 14 gigantic 5-meter diameter dishes, right? 14 of these things on their sun tracking pivot thing, and it was only capable of 25 kilowatts, right? Yeah, so, you know, so that's why nobody uses this type of thing anymore. But they needed to know, right? They needed to research this, so they built it, and they researched it. They built a few more in various locations around the world, and they went, nah, it's better if you have like one big central tower and then you have mirrors that just pivot and focus the sun's rays onto that one gigantic
tower. That's the kind that I had in mind. And then I was
because that's the only ones that you
those
make.
Reflectors, they must catch a lot of heat. I mean, obviously they catch a lot of sun, right? And they're bouncing photons, I guess.
But they're mirrors, so they don't actually absorb it, right?
Right, but they still must have some absorption. Right?
Oh, no, well, it's going to be non-zero, but it's not going to be. I don't think it's, you know, it depends on the efficiency of your mirrored surface.
I guess they're always out in the middle of like deserts too, and I'm like thinking like if you're out in the middle of a desert anyways, it's like the ground's pretty hot as well. So maybe I'm just like thinking about it being like that hot because everything else is around, or I guess full sun.
Yeah, but it's not much, right? Because if you think about it, right, the regular solar insolation, let's run some mental numbers here, right? 1,000 watts per square meter, right? Let's say each mirror is 10 square meters, right? So that's 10,000 watts for a 10 square meter mirror, right? A single mirror, right? Yeah, you know, 10, so we got 10 kilowatts, right?
But then you have... I don't know what the conversion efficiency is, you know, like...
Well, at times, like, let's say it's 0.1%, like, loss, that's only 10 watts. So that entire 10 square meter... So that's only one...
You think it's that much? You think mirrors bounce that much power?
Well, I assume that the materials technology is so good that a mirror is... You can get close to 100% efficiency on a mirror, I would think. A nice polished surface, I would think, mate.
What about, like, super low... what I'm really thinking about is like there's like high frequency stuff and then there's low frequency stuff, and like, you know, some infrared comes in with the sunlight, and that's like super long wavelength. I didn't think that mirrors would bounce that as well. But honestly, I never even thought about the efficiency of a mirror. Like it's just a mirror, right? but at a certain point, it probably does start to add up. Yeah.
Yeah, well, yeah, exactly. I don't know. I'm looking at the moment. I'm looking at Solar Mirror Wikipedia page, reflective layer for reflecting the solar edge. In most cases, and first, I'm going to search for efficiency. Reflection coefficient.
I know someone who will figure this out.
Right. Okay. Efficiency. Come on, just give me a percentage.
Dave, you can just you just put this on your. So Dave and I are actually recording. We've had a bit of a couple snafus now with a past recording service. So we're using StreamYard, and we have at least video to one another. You could just drop this. I could look at the stream video right now, Dave. You could just put it on that window.
You could. Well, okay, fine. Look, here it is.
We'll share together.
There you are. Yeah. There you are. Look, solar thermal application. It's. Come on, there's got to be an efficiency. Yeah, this is where ChatGPT, right?
You do think it would have like that as a banner level thing, yeah. What is the efficiency of a mirror, I guess?
What is the efficiency of a solar mirror? Damn it, I'm going into ChatGPT now, right? I'm going to go OpenAI, right? Hang on, this makes for great radio, right?
Yeah, we can We can edit this pause out.
ChatGPT. I mean, because so are you a paid ChatGPT person?
I am now.
Have
yeah.
you? Okay, yeah, which means you have access to the live thing, so you can actually search.
I actually didn't know
for
that.
live search results. Oh yeah,
I don't use it that much. I use Midjourney way more. I pay for both. Work pays for both. Yeah, I use Midjourney way more.
Right. What is the efficiency? I spelled efficiency.
I'm sorry, Dave. I can't do that.
I do that of a solar thermal mirror. I assume it'll know where. Here it is. Solar thermal mirror systems, also known as concentrated solar power systems, use mirrors to concentrate sunlight on a small area. The concentrated light is then converted into...
It sounds so like pedantic when it starts.
I just wanted an answer.
Just put a number at the top, like I want that number like on Google.
Oh, hang on. Typical optical efficiencies are in the range of 60 to 70%.
Oh, lower than I would have guessed.
That's for the optical efficiency. Thermal efficiency is 80 to 90%. Hang on, conversion. No, I want the overall, the combined. No, I just want the actual mirror. I don't believe.
The exercise is left up to the reader.
Really? I just don't believe that. I don't believe that it's like barely gets to 90%.
Well, I guess the other thing too is that like the optical efficiency then too, like just thinking about that. So say 60 to 70%. What is that 30 to 40% number then though? Does that get converted to heat? Or is that just like bounces off in random directions or, photon?
Well, you've got to assume it has to be absorbed, right? Because it's a surface.
No, sure.
It's an actual surface, right? And if you've got your 1 kilowatt per square meter focused at the sun, because these are angled, right? So they're angled properly, right? Yep. So they're angled optimally. So you're getting your full 1 kilowatt per square meter.
Is that like a standard kind of like a back of the envelope kind of number? I actually don't know.
Oh no, yeah, that is the industry standard. The solar insulation for a solar panel. If you look at the data sheet, it's all it's if you've got a 400 watt solar panel, that's at a nominal 1,000 watts per square meter. That's taken as the solar insulation.
That's
around
like
the world.
A great, easy to remember number.
I know,
really
it's
nice.
awesome. Yeah, it's awesome.
Thanks, son.
So in countries like Australia here, right, in a high solar, it might be slightly higher than that. In Sydney here, it might be slower than that some days, but I've actually looked at data, and even in Sydney here, it can actually get higher than that. But that's taken as like a worldwide average. So they just rounded it. Somebody somewhere just rounded that off to the nearest.
Not in Cleveland, Ohio, I bet.
So, right, no. And of course it drops in winter and stuff like that, but 1,000 watts. But every solar panel you'll ever get, the data sheet, have a look,
standard,
rated at 1,000 watts per square meter, which makes it which makes it fantastic. It's just
that's nice,
really easy. So I'm not happy with ChatGPT.
So not 100% though. I think that's pretty clear. It's not
100%, but I would have been stunned
if
it was more than the.
I mean, that's an order of magnitude off, right?
Okay, well let's say it's
10% inefficient. I would say that makes sense. I mean, like just thinking about otherwise, why wouldn't they do this? Yeah, but I can
understand you would get that as a system efficiency, right? Yeah, I can understand that the system's only 60%. In fact, this one that I was looking at, the entire system efficiency is only about 20%. If you take end to end, like 1,000 watts per square meter in, and then you've got not only the concentrator itself, but then the engine and like the steam generator and everything, and the entire.
Right, then you start running into Carnot efficiencies as well.
Right, and you've got like 1,000.
That was on a video recently.
Was it?
Who was it?
Okay.
Yeah, I think Real Engineering or someone was talking about efficiency. Maybe it was Veritasium. I don't know. Somebody on the YouTubes was recently talking about Carnot. It was great. Yep. I love Carnot.
So there you go. You've got a 5 meter diameter dish. I don't know. You have to do your pi r squared thing to work out the area of that. But, let's say it's 5 square meters. So you've got 5 kilowatts coming in. You're only going to get 20%. Or no, it's even lower than that. I think it might have been 12% or something. It was like, it's actually quite poor system end-to-end efficiency. But I can't believe a mirror is not like 98, 99% efficient. I'm not buying it.
Dave, we may be blessed with some mirror experts right now.
Right, or, screaming in the comments.
At the very least, some mirror armchair experts.
And next week on the show, we'd like to announce the world's best mirror
foremost mirror expert. Yeah. I feel like that would be a different podcast too. I don't know what the crossover would be of like material science experts and because it does feel like a material science field.
Yeah. Oh, totally.
Even like a PV expert is going to be someone who's probably not like doing microelectronics every day.
They would be
doing
a
semiconductor physics every day.
You would be a physicist, a material
Process
scientist,
control
something
engineer.
like that.
Yeah.
So what would have your guess have been? I mean, I thought like engineers, that's what we do, ballpark assumptions.
I've been spoiled now, Dave.
Right? Yeah, exactly.
I was spoiled by now, learning that we should have had me guess earlier. Here's what I was thinking. I was thinking the mirrors were going to be hot.
Right.
So whatever that translates to in efficiency, because, I just assumed that...
Yeah, but I thought they wouldn't have been, because that's their job. Their soul, you have one job. Your job is to reflect the energy. And I thought material science these days.
I think the IR stuff that hits the Earth, right? That's like low frequency and... No,
I think you're overcomplicating it with this frequency.
You ever see that animation of like how AC passes through a waveform and then it shows a sine wave and it's just going through the gap of a capacitor rather, and it's just like, oh, there it is. Like that's what I'm imagining for large. My brain is very stupid and getting stupider by the day.
Right. Oh boy.
But I have fun doing it, so I don't care. So that's why I was asking about it. I was just thinking that these things would be kind of kicking off some heat.
Yeah, but maybe I would think it'd be minimum. Just like when you talk, okay, do you know the efficiency? Well, no, we've talked about this on the show before. We've even had guests on. Do you know what the efficiency of a power transformer is? Like a mains distribution megawatt power transformer is, right?
I know it's not 100. I don't remember what it was. Who's talked about that? Was that the sheep farm guy, the one who was doing like lightning stuff? I don't remember what his name was.
Oh, okay. No. But anyway, like, right? Just so you don't know.
I don't remember. No.
Do you think it's near 100%, or is it 90%, 95, 90, 85, 80?
60%.
60%. Okay.
Yeah.
So you're telling me that a 1 megawatt. A 1 megawatt.
Oh, that would be kicking off a lot of heat, huh?
Yeah, exactly. The transformer would melt, right?
It would definitely
melt.
So
by practical engineering inspection.
Whoa. Nobody ever has claimed I was a practical engineer.
It's got to be high, right? It's got to be close to 100%. It's got to be 99%, right?
Yeah, I guess I didn't really think about the big boys.
Didn't you ever do a power engineering class? That's one of the first things they taught us. Was like,
I never did.
They actually got us to do this very thought experiment.
That's a good one.
Right? They said, think about it. Like, how much loss, right?
Well, I think it's once you start thinking about the loss, usually goes to heat, if not RF, and then
Well, a transformer, right? Yeah, it's going to go to heat, right? You would melt the insulation on the wires in the transformer. It'd just melt and short out. Right? If it's more than a few percent, even. If you're talking about a 10 megawatt transformer, for example, right? Just, right? It's these.
So you're saying the same
they're
thing
incredibly
here.
I'm saying the same thing here.
The mirrors would also melt but you're not forcing the same amount of power through a mirror.
Well, no, because there's not much energy coming on them. Right?
Yeah, exactly. Things sit out in the sun all day, every day, right?
Yes.
So that's
of course. And they get hot, right? They get hot enough to.
Yeah. You ever gone on? Here's a little life experience thing. You ever go down a metal slide at a playground in the
right.
in the noonday sun? Better be wearing long pants.
Yeah.
These lived experiences these days. Yeah.
Yes, exactly. Anyway.
But I guess probably the sheet metal on a slide is probably not meant as a efficient mirror either.
Right. But I'm thinking.
You're in the 90s.
It would be in the order of like 99%. I would have been surprised. I will be surprised if it's more than a couple of percent loss. But hey, I don't know.
It's a good question.
Is mirror optical technology not that good? I don't know. Anyway, ChatGPT useless. Yeah.
Yeah, seriously.
Fail. Yeah,
good luck taking over the world,
dumb.
computers. We already have enough dumb over here. Thanks a lot.
Oh, boy. Anyway, that's enough of that. Anyway, that was fun.
Yeah.
So hopefully I'll have a video coming on that. It's
cool.
Not hugely informative because I didn't know I was going to this thing. So if I did, I would have done some research maybe.
Look at this.
It's like, but here it is. I don't know. Wave my hands and... Yep. Anyway.
I also was traveling. I just was in Prague 2 weeks ago for the Embedded Open Source Summit. And actually my talk was published today. So I gave a talk about training.
Is that the one that's linked in?
Yep. That's on the Reddit
Oh yeah, I see
right
it now. Yes, I see it.
Yeah, it was pretty good. Definitely the best audio I've ever had for a talk. They gave me like a little like one of those mics that's like real close to your face. I've never had one of those before.
Oh, the headset mic. Yep.
Yeah, like the one they give singers on the stage.
Yeah. It's a headset.
Yeah, not like a Gwen Stefani headset though.
What's a Gwen Stefani headset?
Gwen Stefani like had she was like No Doubt, the singer from No Doubt. She was like
but
famous
like
for
I've heard of her. But
and like Madonna had one too, but it was like actually like a large black microphone that came in front of their mouth.
Oh, okay.
And this was actually like beige and like the small microphone.
Yep.
Really good explanations here, Chris.
Actually, that is not a small one, dude. No, sorry. You're out of date with your microphone technology.
Okay.
That is not a small one. No, that's actually quite large. Yep.
I'm so ashamed from that and not from thinking that transformers would melt throughout the power system.
Right. Oh, boy.
Yeah, but this is about how I do remote machines, basically, for training and kind of like all of the challenges. How I would prefer if people would show up at a training with a completely new OS installed on their laptop, and that is the stupidest assumption you could possibly have. Nothing could be further from the truth.
Yeah, exactly. Yep.
So past guest Joe Fitzpatrick, he does hardware training, and he actually rocks up to training with 2 or 3 Pelican cases full of laptops that are like imaged the night before. I still think that is, if you're going to do in-person training, which I'm not, I'm doing remote training. If you're going to do in-person training, I think that is by far the best one, because then you get USB access, and like you can just you really know, that's what kind of like the thing what people expect out of a computer based training. So yeah,
nice
training
seems like a packed room.
Yeah, this was definitely the most full room I've ever given a talk to. Usually it's like 4 people, 3 of whom are very nice Amp Hour listeners.
Right, yeah. I'm surprised it's not higher. So what? So there are only 3 or 4 in that crowd who actually knew who you were?
No. I'm saying in most talks I usually give, it's only 3 or 4 people in the room.
Oh, okay.
Total,
right. Okay.
Of which 3 of them are Amp Hour listeners, and they're like taking pity on me. They're like, "Oh, I heard Chris is going to be giving a talk."
I'll sit there and show some moral support. Yeah. Right.
Exactly. Yes, and I really appreciate it. I mean, I really do.
Oh yeah.
But a bunch of people in this room didn't know who I was, which is great. That's what I'm going for.
Oh, excellent.
So it was fun. It was a cool town. I'd never been to Prague before, so
yes, I heard it's nice.
And yeah, great folks from Czechia and elsewhere. Czechia. I'm not sure how to say it. From the Czech Republic.
Right.
Yeah.
I won't even try to butcher it.
Yeah.
Yep. Cool. And where are you headed off to tomorrow? Well, you're packing tomorrow.
I'm packing tomorrow. On Friday, I'm going to the Pacific Northwest and doing some more national parks with my family.
Oh, okay, right. Yeah. So this is personal. It's not.
This is personal. Yeah. This one is. This time it's personal.
Are you going to slip one in there? Are you going to slip in a tech visit?
I'm going to meet up with our good friend Jeff Kaiser.
Oh yeah.
Mr. Mighty Ohm himself. So we're going to meet up with him and a couple other nerds along the way. But
okay. Yep.
Yeah, that's about it. No meetups or anything like that. I'm pretty strictly on, family schedule. So.
Yep. Somebody emailed me yesterday and asked if there's any decent tech events here, and I'm going, no, there's just not. It's sad. Yeah. There's just nothing. Yeah.
I think you got to respond with, you should start one. I think that's the way to do it.
Right. Okay.
Right. That's what you should really do, Dave, next time.
Yep. Yeah. But the problem is, I can't even get together a bunch of YouTubers. It's like, okay, I'm there's a couple. I don't think there's any. No. Are there any other electronics, even tangentially related electronics YouTubers in Sydney? I don't think so.
I don't know.
There's a couple in Melbourne, but it's like slim pickings.
Sure.
So whereas, US or even Europe or UK,
Yeah, I mean, YouTubers is kind of a smaller audience, right?
Yeah.
Here's my advice, which I don't always take myself, so take that with a grain of salt. The best way to start a meetup is, one, to put it on some site where people will hopefully find it, like Meetup or similar. I'm not a huge fan of Meetup itself, but it's fine.
Yeah, no, I've kind of ditched it. Yeah.
Yeah, it's not the best, but the most important thing is to tell yourself, I'm going to hold a meetup, and I'm going to be at this bar at this time, and I will be there with electronics projects, and I hope you show up. And if and you're going to go there, and you're going to enjoy a burger and maybe a drink.
No, totally.
And if nobody shows up, you have to be okay with that, right? That's the important thing.
Exactly.
Yeah.
Or if
it is
one
putting yourself
person
out
shows
there,
up.
but if one person shows up, you're going to hang out with them. It's going to be great, and then maybe try it again later. So it's tough. It's tough to get people together, but you do it over time, and enough people find out about it. The hard part is people finding out about it, I think.
Yeah, totally. So
if you're going to start one in Sydney, tell Dave so he can amplify it, and Dave will definitely amplify it.
Yeah, I'll probably do the EEV blog thing again, the meetup, because we had 50 people last time. It was quite a lot. It was actually, the venue was pretty much packed. So it was like standard room only, really.
Great, do it.
I
dare you.
Exactly. but it's not, it's just a hangout. It's not a event, which is kind of different.
Hangouts are great.
Yeah, I know. Hangouts are great. But I'm wondering, would people likely to turn up to a hangout, just a casual hangout, than they are to turn up to a formal event? Like if I organised, talks and, if I held a venue with a, seating and, I'm thinking I'd be struggling to get people to turn up to that. Whereas a hangout, I think...
You'd be surprised. No? I think people are always looking for technical content and stuff like that. I mean, I used to do these things all the time, so... Yeah, no, you'd be surprised. Because, then you actually... If you publish what is going to be talked about there, too, it's like...
Right, yes.
I don't know, some of that... There is something about the being in person, right? Obviously, we're all coming out of the pandemic. And then I think wanting to be part of this live event where it's being talked about too, and so someone is going to give a talk about what's one of the ones that used to go. So how about this? So maybe a bit news relevant. This guy Nick Bingham, I think, he gave a talk at HDDG, which is a meetup I used to do, about high pressure electronics for submersibles. And if you gave that talk these days, right, there would be a lot of interest given the recent events. With OceanGate.
I should have done a video on that, but I said I wouldn't. I said I wouldn't do a video on that, and people thanked me for that. But now I'm watching all the videos on it, and they're getting 2.2 million views, and
I'll send you this one. It's worth watching. It is.
I've probably already seen it, but okay, send it.
And then actually another person that was at that meetup, he's actually the guest for next week. So and I've mentioned him on here a bunch before. So that's Werner Johansson. So, yeah.
Cool.
And bananas. Just like you have these weird topics, and sometimes...
Where's the link? I haven't got it.
Oh, sorry.
Yep. Come on.
Where is it?
Press enter. It's that big. It's that bigger key. It's
the middle key.
That double width key.
Press the any key. Oh, where's the any key?
Oh boy.
I think it would work. I think you just gotta, the logistics are the shitty part, personally. Getting people there.
I have not seen that one, because that's a supply frame hardware thing. Okay,
that's right.
So this is not OceanGate. Okay, right.
This is not OceanGate. No, this is way before. This is from 2017. But it's basically about what happens when you compress capacitors at whatever the thousands of meters depth thing, right? So even if you have a fully enclosed case, but then all your all of the all of the epoxy that you put in there or whatever's enclosing this thing is still going to get compressed, and then can all of these things withstand even just the nominal pressure after you have these enclosures? So it's crazy stuff.
I know, I've worked in that industry.
Yeah.
Tell me all about pinhole leaks in cables. If you think your PVC cable, if your regular cable doesn't have pinholes in it, I've got a bridge to sell you. So, anyway. But it also depends how long you want your stuff to work underwater. It's
Right.
it's also a thing. Like so
Yeah, right. There's trade-offs there.
some stuff I've worked on was reusable. Others, it just had to work for 4 hours and then it sunk to the bottom. They're very different design criteria.
Right.
when you
Agree.
when it's actually sacrificial.
So I think you should do it.
Which one? You got to tell me which one.
Oh,
The actual, like, the talk one or the meetup? The meetup one's easy, like, because it doesn't cost anything.
Easy.
You don't have to organize anything. You've just got to actually publish it and turn up.
What is the most likely thing for you to do, Dave? I mean, that's really
the one with the least effort.
Yeah, then do that. That's great.
Exactly. Yeah.
Yeah, then do that.
Okay.
And then if you enjoy it, then do the other one. I don't know.
Well, I've already done them before, and I did enjoy it. So
then
I
do
just
them
have to
again.
get off my
Okay.
ass and get off. And exactly.
Yeah, I think that's the real thing. That's the real thing. Yeah. Speaking of, I have to get off my butt and make a board. I finally did get off my butt, actually, and finally tried out the CH32V003, which you had made a video about, and you and I bought that board at the same time, and it took me having CN Lore on the show talking about this thing in order for me to actually try it. Have you done anything else with that since you started with the Moon River?
Not much, no. I just had some play around with it, and that was it.
Yeah.
Unfortunately, it's not a chip that's suitable for my current project. So
right.
It's just
Yeah, I am wondering some of the limits on it of like the specs and stuff. Like I'm still mostly going through examples and trying stuff out. I will say, so CN Lore talked about it during the recording, but like it is the fastest compile time. Like the compile download try loop is so incredibly fast. I've never experienced anything like that. And I don't know if it's like because the tool change is so minimal. This is using his...
It's minimal, plus it's not very big. I mean, it's not like it's got to download megabytes worth of,
It's not big, right, exactly.
It's only downloading like 1K worth of code or something.
That I think, there's not a lot of code. And then also the one thing that CN Lore did point out is that the interface speed with the one wire that's on there, like the debug port, is actually very fast as well. So like that's another factor, I guess. I don't know.
Right.
So, I'm excited about it. Got to figure out what to build. I think I'm going to try some of the things that he talked about too, of like building a buck converter and similar things like that. Like some of the build your own
that's
system
just
type
wrong.
thing.
A buck converter with a 32-bit with a an ARM
with a 10-cent microcontroller.
But it's just it's wrong.
Why not? That's also what Werner talks about next week. Hey, this is how people do it, man. But here's the thing. So this is one thing we talked about when you weren't here. Was like, what if you could always get this chip though? Granted, that's a very, very long stretch in the current world we live in.
If it's so jelly bean that it's that you use it for everything.
If it's so jelly bean, say it gets replicated by other people too, right? Say this form factor gets really replicated. It's always 10 cents, whatever. And it's, I don't know, 80 to 90% good enough as like a TI switcher. Like maybe it does make sense to put this in there. Like TI switchers are great. I love them. I put them on parts all the time, boards all the time. But like, if I can control it and maybe customize it more, like that, there was a lot of that push-pull of like, should you maintain this stuff too? Because then there's the burden. One of the things I brought up was the support burden of like maintaining 5 pieces of firmware on your board. That sucks.
Yeah, right.
So you do have to balance these things.
Have some self-respect. Come on.
What's the self-respect? Just buy a switcher.
Doing proper engineering and using the most optimal part for the job. Not
sure.
Just like...
No. This starts as an academic exercise first, but I think there are cases for it.
The road to hell is paved with good intentions.
That is very true.
Is paved with academic intentions.
I think the road to hell is paved with. Well, how hard could this possibly be?
Oh God.
But
no, it's just.
I want to know how hard it is too. I've built switching converters with like 555s before, but I've never done it with micro.
Yeah, because it's overkill. It's just
totally it's overkill.
It's just the wrong part for the job. Sure, you can make it work.
Sure,
but like, should you?
Dave, you're not going to talk me out of this, man. You're not going to talk me out of this.
Fine.
Maybe you should. Maybe that's what the real thing is. Maybe you should.
Right.
Maybe you should follow along.
No thanks. I've got too much self-respect.
You got too much self-respect. Okay. Okay. All right. Well, let's hear about your recent build then. Tell me about all these parts that you're putting into your board.
Well, I've done some videos on it. It's an optimal part. It's got everything I need built in. It's got the LCD controller. It's got the low power. It's got the 32-bit timers that I'm looking for. It's got, I've done a whole selection video on it.
I've watched the videos. Yeah.
Yeah.
What about the other stuff on board?
Oh, there's not a huge amount on there. It's not a huge amount else. So unfortunately, it's like, and so it makes sense to sort of like optimize the one part.
Okay.
Yep.
Yeah.
I could have done it with one of these little 10-cent micros, and then I'd need an external LCD driver chip, of course, and then I would probably need some additional, timer thing, maybe a CPLD or a little, something like that perhaps, and then I'd need does that have a real-time clock in it? The CH? I don't think so. No, right? So, so I'd need a separate real-time clock chip, and it's just meh. Yeah, sure I can.
Oh, maybe it does.
And that's what you would have done in the 1980s, right? That's what I would have done, right? I'd be using 774 series logic, or a CPLD or something.
Oh, no, the 107. The CH32 V103 has an RTC.
Oh, okay, right. So there is a variant that has it. Okay.
Yeah, there's definitely stuff moving up the stack too. Like there's a F1, F3 family, or V1, V3 rather. I think they're just mostly replicating a lot of the STM32 stuff.
Right.
Yeah.
I've got a segue. I've got a perfect segue.
Hit it.
You've already got, it's in the list, but I will send you the link now so you have it. It's an article about, it's in the Wall Street Journal, to drive AI, chip makers stack chiplets like Lego blocks. It's the old modular electronics thing, but at a silicon level. Yeah. So there's this new standard. There's this new chiplet interconnect standard, and I can give you a link here. And we'll link it in down below. But a chiplet is basically a pre-existing IC layout, right? So a pre-existing chip layout, but then you can join them together with a bus. And there's various standards for this. One is UCIe, and there's another one, which I like the name of, Bunch of Wires, BOW. I like that, Bunch of Wires. There's Open HBI and there's OIF XSR. Geez, no, bugger that one off. You can't even say it. A bunch of wires sounds good, but the UCIe, if it sounds like the PCIe, you're not wrong because it's a serial interface. So basically, major companies like NVIDIA, AMD, Intel, Microsoft, Meta, Qualcomm, Samsung, TSMC, geez, they're all in it, right? So all these companies are sort of like agreed to this Universal Chiplet Interconnect Express interface, right? UCEI, and it was only released in March 22, so it's relatively recent. And I think chips are coming out now that use these chiplets. So the idea is, okay, Intel's got a CPU, okay, I'll use that, and Qualcomm's got some sort of what do Qualcomm do? The the comms stuff, right? So it's got some comms thing over here. So you join all these together so you can make an ASIC using off-the-shelf chiplets, and it reduces the design time.
Well, Dave, if you search on the Amp Hour for chiplet, you will find episode 469, episode 499, episode 519, episode 535, episode 616. Yes, chiplets have been, although none of them were, I don't think they were talking about the standard, so that's actually interesting.
Right, okay.
I would say probably the closest one is Ming Zhang, who was on the show. He was at the now defunct Zglue, where they were basically, instead of using a standard, they were basically making like a kind of like an FPGA fabric where the chiplets went onto that.
Right,
it wasn't an FPGA though.
No, it's right.
Yeah,
okay.
Smart fabric. So it was like reconfigurable.
Well, that's a different way to do it. There's many ways to do it. Yeah.
Yeah, totally. Yeah. But it's definitely a big trend. I think especially like because once you move out of like I think some of them are still wire bound, but like I think wire bonded rather.
Yes, you can wire bonded, so it's not really like it's an ASIC, but it's a hybrid
ASIC.
It's
like somewhere between a SIP, a SOM, and I don't know what the hell all these different things are. And then like Z-Glue was like basically it was more like almost like a mini circuit board is kind of how I thought about it, even though it wasn't quite there.
Yep.
And yeah. So no, it's definitely a cool idea though.
Yeah, it's all about the standards. It's all about, okay, how easy is it and how does it suit my system requirements? Because if you go on a serial, this is a heck of a serial bus. It's 32 gig transactions per second with up to 64 lanes, right? Yeah. So, it's like, it's pretty kicking ass.
Right. And this is like that kind of system design type thing. It's like whenever you start shuttling data and you have buses between them, then that becomes one of your bottlenecks, right? So like, then you really have to...
And then the physical distance. That's why the hybrid, exactly. if you're doing the hybrid, okay, you've got the multiple chips and they're on the one substrate, but you've got the physical bond wire which has to go over, and that's just, okay, you've just slowed your throughput down because you have to go through like a 5 millimeter long bond wire or something.
Right. And then I think the other thing too is that you have to like balance, especially with like the high end like NVIDIA type things. I remember reading something about like the amount of heat you generate and then how much you can, like how close can you actually put stuff together, right? There's like some equation there for like, you need to localize your heat because you're just burning so much because of the efficiency of the core that's processing this data. But maybe you could put another chiplet next to it that you're shuttling the data, so you lose the efficiency. So you lose the data throughput going from one chip to another, but maybe you gain that power going external to the spicy chip. And
you might have thermal differences between those, so you might only want one of them going to the thermal pad, for example, and not all of them, because you don't want to. You want to take your heat away from the die that gets hot, but you want to, or the part of the die in this case that gets hot, but you don't want to, like, as much as possible spread that heat to the other parts of the die that aren't getting warm. So you want to sort of like extract it out from the hot spot, so to speak. Yeah. So I don't know, all that thermal packaging stuff.
Yeah, another one. So like I think more at the level of, so like Ming was doing the Z-Glue stuff. Craig Bishop, who was on the show too, he was doing like, I think his was more like substrate. He was doing like because he talked about an auto router to actually put chiplets together, but it was
right.
The ability to create this. The substrate was ultimately the product that that company he's working at. So yeah, I'm sure this is definitely a big. And you think about like the complexity too. Like you don't want to. Yeah, I just think about the processing differences of like a lot of these chips in the realm that I work on, right? Like something that can do RF power output.
Yeah, RF stuff
it's got a microcontroller on board.
Very different
and then,
process. No.
Right. Right. Yeah. Or like you look inside you look at a die shot of an espressive part, right? They have these huge inductors and capacitors relative to the rest of the chip. But then, you still have to have all the transistors as well. And then just putting these things side by side, at some point, the scale difference is so high. If you want to have all these functions pushed together, it makes sense to just separate and do them on different processes as well. Because, the amount of space you might waste in a 22 nanometer process to make a large resistor or capacitor on silicon, it's like, well, maybe we should just take that off the chip, right? And connect them together later. So it's like the process efficiency stuff. Glad I don't do that stuff, Dave.
The old jack of all trades, master of none,
Yeah. Well, I focus more on that second part of that phrase.
So, but this won't be, some people talk it up as, it changes the entire industry. No, it doesn't. It helps out in some areas, and in others, it's a complete hindrance. So no one's going to touch it, right? It's like.
I'm really surprised. Have you looked at valuations of like chip companies these days? Like
no,
Intel is like
what's happening.
So like, NVIDIA is one of the biggest because they've gotten really ramped up from.
Yes, I've heard that NVIDIA's gone gangbusters recently, but I haven't looked at the chart.
I saw a chart, and like Intel was. I think it's like Intel's like at one. And again, this is investor like valuation, right? Not necessarily
yes.
like
this is share
good for the world or actual like sheer.
Ship NVIDIA in the last year has gone up 400%.
Yeah, it was like a comparison of all of them, but like NVIDIA was one of the biggest, and then AMD is bigger than Intel now because they've been rocking in a lot of fronts. I was just mostly surprised about Intel. Intel's just a little sad.
Well, Intel's, if you're in the computer business, if you're in the Linus Tech Tips business, you'll know that Intel's been languishing behind, let's say that. for
so like people are
quite a lot
switching
of years.
to AMD for other stuff.
Yeah. But I've heard it's swinging back, but I could be wrong. I don't know. I don't really keep up to date on that.
Yeah, my computer's not very good.
Intel's gone down a bit, but, it's actually recovering at the moment. Intel's actually recovering, but just a little bit, slightly. But,
You're just looking at charts and stuff.
Yeah,
like that.
I'm just.
I would
looking
just
at
just total like just the size of these companies. I mean, one, I was surprised by how big Nvidia is, and two, I guess I was surprised by Intel's relative shrink comparatively.
Yeah.
So yeah.
Oh yeah, AMD. Oh yeah, AMD's gone from. Oh god, AMD was just. Oh well, no, I am looking at quite a timeline there. But we're talking about going from $19 to $150. So, that's almost a 10. That's getting close to a 10-bagger, depending on when you bought it. So, geez.
Yeah.
Wow.
Well, the other thing, too, is I'm not sure that actually represents, like, shipped product as well. I think those are always priced for
all
the future, right?
No, exactly.
They're looking at NVIDIA and how much it's, like, in these AI applications with GPUs, and they're looking very far forward, and that could crash as well, but...
Just remember, folks, to buy the rumor, sell the fact. Okay, that's like that's how the share market works.
I don't know that one, Dave.
Okay, well, you can go Google that one.
Okay.
Buy the rumor,
Jim
sell
Cramer
the
of
fact.
electronics over here.
Right. The inverse Cramer rule. I'm a big believer in the inverse Cramer rule.
Yeah, that's a good one. That's a good one.
Yeah,
buy,
that's great.
Buy whatever he's saying to sell.
Yeah.
That's probably a good idea.
Totally.
Yeah.
Yep. Apparently, it's got like an 80% hit ratio or something. It's pretty good. It's very predictive. Yeah. Oh god.
Speaking of, well, not speaking of. There was a large purchase of a company. I think maybe we talked about it in the past show, but NI got bought by Schneider Electric. No, who did they get bought by? It was someone I was surprised. National Instruments got bought. Not National Instruments. Sorry. Shoot, who owns Digilent? Digilent's owned by
NI.
It is National Instruments.
Yes, it is National Instruments.
I was thinking National Semiconductor. Okay.
No, National Instruments. Oh, what? So you're saying somebody bought National Instruments?
Emerson Electric bought National Instruments.
National Instruments. So
that was 3 months ago. Okay.
Yeah. Right.
So that was a while ago.
Yeah.
But I also wanted to bring up your Digilent.
Yes.
Your Digilent review. We both have the Analog Discovery 3.
We both have the Analog Discovery 3. They sent it to us. Yep.
It's my daily driver now.
Oh, okay. Yeah.
Yeah.
Yeah, it's pretty cool.
What do you think?
Oh, I think it's great.
Are you going to use it regularly or no? I'll link in Dave's video about it.
Not really, because I have other tools like, Well, I'll see how it goes for my streaming recording platform where I have an on-screen scope and an on-screen multimeter, but this one doesn't have a proper multimeter in it. Whereas I've basically got a bigger version of this. I've actually got the NI.
Oh, you got the bench one, yeah. Right.
Lab thing or whatever, and it's got a proper multimeter in it. It's got a proper power supply, and it's got
Right.
So yeah.
This one's coming on the road with me on my my trip. So
which annoyingly, what they did, right? Because NI, before they bought Digilent, they used to have these. What are they called? Bloody hell, I can never remember the name of the stupid thing.
Yeah.
NI Lab. Come on, help me out.
I don't know. I don't have it. Look at your bench, man. Aren't you in your lab?
No, I can't. I would
literally
have to get
turn your head, go look. I don't care.
Oh, right. Fine. I'll go.
Oh, actually, I have it right here. Virtual bench. It's virtual bench.
Here we go. I'm back. Hang on.
Wait. Dave, is
Headphones back in.
Is it the virtual bench?
Virtual bench. Yes.
I had it as soon as you stood up because there was another post here on the Reddit from 8 years ago. Holy crap! 8 years ago. Wow.
Oh, really?
Wow. We used to get more votes on our subreddit stuff too.
But yeah. So they had this virtual bench, right, before they bought Digilent, right? And then when they bought Digilent, what they did is they took one of their virtual benches and they renamed it. So if you get the Digilent Pro or whatever it is, what's it called? The Digilent... No, it's got some other weird name. It's got some other weird number or something.
Okay. Analog Discovery Pro?
Yeah, but no, their big one. No, it's not the Pro. It's the test and measurements. It's the... shop all.
While you're doing that, I actually would like to point out that if you search on Reddit, actually, you search on the Amp Hour subreddit, you can actually like go back and like look at the history of when we were talking about things. It's pretty interesting. I know this is a stupid realization of like, oh look, the search works on Reddit, but 9 years ago I asked, why are fabs located where they are in the U.S.?
Oh, there you go.
Yeah.
Anyway, it's the Analog Discovery Pro ADP 5250. Bloody hell, right? But that is just a rebadged NI
I was right.
What?
Analog Discovery Pro. I said Pro. I'm looking at one on my bench.
Yeah, but there's two Pro ones. That's the Pro 3000. You've probably got the Pro 3000, right?
Yeah, that's the 3000. 3450. I have the 3450. Yep.
Yeah, that is different, right? I'm talking about the ADP 5250, which is identical to my NI virtual bench, right? So what I want, damn it, it's just a rebadged product, yet it works with the new waveform software. And the waveform software is way orders of magnitude better than the old NI software that I've got for my beast.
Yeah.
So I'm wondering, can I actually...
Yeah, I think it's easy to say Digilent was a software company first.
it was a software company, yeah, exactly.
That happens to make dev boards. Yeah.
Yeah, that happens to make, little oscilloscopy interface things, which is basically an FPGA with an analog to digital converter stuck on it, kind of thing.
Yep.
And so I want to use the new waveform software, but I've contacted them on Twitter and they never got back to me. So bloody hell.
Literally
anyway.
they email us all the time. But...
Yeah, I know.
Okay.
Oh, do they? Oh.
Yeah. I'll send you the email afterwards.
Oh, okay. Right. Who? NI or Digilent?
Oh, Digilent, yeah.
Oh, right. Okay. Yeah.
How about this? 9 years ago, I asked on Reddit, why are fabs located where they are in the U.S.? And I said,
yes.
I was talking to a friend about this today, wondering why someone wouldn't up and build a fab in Cleveland. But they're building one pretty close. They're building one in Columbus, like 2 hours away. Look at this.
Right.
Chris is predicting the future. 9 years ago, Chris. Nice job 9 years ago, Chris.
Where's the...
Oh, this is...
Is there a link?
No, I'll send you a link, but it was me searching our subreddit.
Right.
Yeah, no, this is a long time ago. I lost our window. That's sad.
I didn't even know you could search a sub. Oh, yeah, search Reddit or search a subreddit. Okay.
Yeah, search a subreddit.
Oh, yeah. Right.
Yeah.
I don't know. I don't use Reddit.
I don't either.
Everyone's now saying Reddit's dying.
Reddit might be going the way of the dodo. We'll see.
Yeah. Your reason, talent, tax breaks.
Tax breaks.
Everything else that seems
tax
important.
Breaks was
Water,
right, actually.
reliable power, good infrastructure. Yeah, tax breaks. Well, it always comes down to tax breaks, doesn't it?
Pretty much. Especially,
come on.
Especially in
Come on,
Columbus.
it's politics.
I really don't have any other reasons. I mean, Columbus, I suppose, has the Ohio State University. Ohio State University. But it's not the top program for like chips in the country. So that doesn't make a ton of sense.
So who's building a fab?
Intel.
Who's building a fab?
Intel's building a...
Intel's building one of their fabs. Is it like a small fab or is it like a...
No, it was a big one. Yeah,
is
it's
it
a real
like a
big one.
TSMC level?
Yeah. No, it's a big biggie.
Okay.
It was basically... That was their CHIPS Act. Remember how all the chip companies were announcing...
Yep.
Like probably a year and a half ago now. They were all announcing. We were excited about it in the show, and rightfully so. Like, I was very excited as a U.S. person, and during the shortages and stuff like that too. Like, they all said we're building new fabs, and TI's got new fabs coming in Richardson, and Intel's in wherever the hell they are in Columbus, and Microchip's building another in Arizona, I think. And they're all over the place.
Yep.
And they've all pulled back. Because they've changed some of the rules on the CHIPS Act. So like they're not.
It comes with a set of golden handcuffs. We've talked about this with Steve Sanghi, CEO of
that's
Microchip.
right. Yeah, that's who brought it up.
Yes.
I was like, I've heard this somewhere. Yeah, so Steve talked about it, and so but they're all pulling back because of that. So it was like these big announcements. I think Intel is indicated they are still moving forward. Samsung said they're going to reinvest in Austin. They're down there. Mm-hmm. So I'm still excited about building more chip fabs. I mean, it's not like a bad thing. I hope they do. I just don't think they're going to be as big. I think they're going to probably scale it back to get the maximum PR and the maximum tax dollars. So,
right.
Yeah.
Mm-hmm. Anyway, there's somewhere on Unmanaged put this link on about China's gallium and germanium export controls.
Oh yeah, that was in the news recently.
what's going on there. Have you actually watched it? It's a 14-minute video.
No.
No. Okay.
I mean, it's like trade war stuff, right? So they control, I think, 80 to 90%.
Oh, yeah, totally.
Yeah.
Yep.
So
yeah.
This is statecraft? Is that what it's called? What's it called? Statecraft? I don't know.
Perhaps.
Yeah.
Yeah, something like that. It's international politics.
There was also another one. There was another, like, I was surprised Norway found like a phosphorus deposit. Was it phosphorus? There was like a big news story about a big deposit found under Norway. And all I could think was of my 6th grade, like, you got assigned a country, and then you had natural resources that you like drew out of a hat.
Right, okay.
It was like you
got like Norway, did
model,
you?
Model UN.
Like,
No, I didn't get Norway. I got some. No. It was all fake countries there, but it was like you had a country, and it would be picked whatever. And I just remember thinking, like, I remember this emotion.
It is a phosphate. Yeah.
It was phosphate. Okay, yeah. I remember this emotion very well in this. So thank you, Mr. Simpson, my 6th grade social studies teacher. It's really unfair. Like, some countries just get a bunch of stuff underneath them, and like, and like that determined
Australia. Yep.
So much of the the outcome of the country is just natural resources. Just
of course.
Wow.
Of course.
I learned that in 6th grade.
Hello,
Dave.
Saudi Arabia.
I learned that in 6th grade.
Yeah. Oh boy.
Yeah.
Yep.
Yeah. It's also what you do with it, though.
It's the world's largest. Yeah,
it's
there
also
you go.
How you distribute that wealth. So that's what I think.
Well, I was going to say, what is phosphate used in? I knew it's used in fertilizers, but also solar panels and electric car batteries need phosphate as well, do they?
Yeah, the electrodes.
Okay. I didn't know how much.
Yeah.
Right.
Yeah. So like lithium and phosphate, I think, are the. Oh, is it? Yeah, I guess that is right. Life EPO, right, or however you say lithium. Lithium iron phosphate oxide.
Yes, phosphate. Yes, of course. It's in the name. Yes.
4. Is that what it is?
It's in the, yeah. Yep.
Yeah.
Yep.
So need some of that P.
Literally in the name.
Gotta get that P, man.
I just didn't know how much. Is it actually a lot, or is it just 2 grams per battery or something?
Right.
I don't
Exactly.
know.
Right.
Is it just like a thin film,
Well, and like you hear about all of these, there's so many unique elements and all these things like indicum and zirconium and all of these different like things that are somewhat trace elements but might be supercritical. Like, you and I aren't material scientists. We don't know.
Totally. Yeah.
Probably important because they put it in the name, but I think the thing that's interesting about their germanium stuff, gallium and germanium, like those are technologies around like which one is it? GAAS? Yeah, gallium arsenide.
Yes, gallium arsenide.
That's the one that's in like RF stuff.
All the exotic RF chips and stuff use that. Yeah, that's.
You know who I can ask is Jeff Kaiser, because I'm going to see him, and he used to work on gallium arsenide.
I'd ask Sharia actually.
Yeah, that's even better.
Sharia would be.
How about this? Let's put Jeff. While I'm on vacation, let's just get Jeff and Sharia in a room. And just let them
Jeff and Sharia they can just anchor the show.
Hey, but this, you call Sharia, and I'll hang out with Jeff, and I'll just hand him the phone. And
right, okay, got it.
While we're eating tacos.
Right, we'll just sit back.
Jeff, you're chewing kind of loud.
Yeah.
Yeah.
Oh boy. Anyway, cool bananas. Well, congratulations, Norway.
I haven't read any of the other links on our subreddit, but once again, managing very well.
There's a whole bunch of Starlink. Stuff in here, and I got a destroyed Starlink board, so I had a look at that in one of my mailbag videos. Yeah, very fascinating stuff, So,
did you know what you're looking at?
Kind of. Yeah. I sort of bummed my way through the video. Yeah, I thought, I
rewatched Shariar's like teardown of a Starlink, like the phased array and stuff like that.
I did watch a bit of it after I did my video because I'd linked it in.
He's explaining it on camera, and I'm still like, I have no idea what you're talking about.
Yeah. But even some of the stuff in there, he was still guessing. He was going, I think it's this.
Yeah, but he knows so much. He's guessing because he doesn't have a schematic in front of him, but like. If he knew...
Yeah, but I'm saying one of the world's experts still has to guess.
Okay.
Because he doesn't actually know, because he didn't actually work on it, so he doesn't know the design stuff that when he can, he's probably the best educated guess in the world, but he still had to guess, He's like, yeah.
We got to have him back on. We got to get him back on soon.
Yeah. Yep.
Yeah.
Well, see, there was one little element in there. when I tore it down, there's this tiny little pinprick hole that goes between the air-gapped sections of the panel, right? Because they actually use float-in element passive radiators, right? So the antenna's not physically connected, right? It uses a two-stage passive radiator, right? Which is basically just a floating piece of copper.
I don't know these words. What does that mean?
Right? It's basically a floating piece of copper, right? Which acts as an antenna. It's not directly electrically connected to the actual transmitter.
See, this is when my brain stops working. I'm like, okay, well,
exactly. I know. It's like
I don't know how that works anymore. So is it like it's like redirecting the beam? Is that an easy way to say it?
I'm not even going to say a word. I'm not going to say. Because I'm going to get it wrong. Right. Passive radiators, right? Anyway. Totally. Anyway, there's this tiny little pinprick hole which goes...
Maybe we should make that the title this week.
Right. Yeah, man, we're dumb. Yeah, sounds
we're
good.
Dumb.
Yep, add it. Yep, lock it in. Oh, boy. And, yeah, so there's a little tiny pinprick between this, what is essentially a hermetically sealed cell between two layers, because it's fiberglass and it's actually glued in place, right? So there's this physical little air gap in there, and it's got this little pinprick hole. And I guess that it was some sort of thermal equalization thing. You know, like the thermal, like you don't want because the Starlink's out in the sun, right? And it's getting hot, and you don't want one side to get hotter than the other, and the thermal differentials could cause sorts of problems.
I hear that Starlink satellites are 100% efficient as a thermal reflector.
as a receiver and radio.
It has to be, or else it would melt.
99.9. Anyway, yeah, so I guessed it was a thermal thing, and then I watched a bit of Sharia's video, and he also guessed that it was a thermal thing. But then somebody in the comments who seemed to know their stuff goes, oh, no, it's also part of the electrical. They do this in the design of the passive radiator as well. It's actually part of the, oh, God, it's like,
Yeah.
Yep.
Totally.
Yep. And I'm sure we couldn't actually get one of the Starlink designers on the show because they wouldn't be allowed to talk about it, right?
Oh, I mean, that would be the last thing they'd ever said, yeah.
Right. Oh, boy. Anyway, it's like magic voodoo, you know?
Yeah.
Yep.
I mean, that's the thing. Like, at a certain time, like, you know, you talk to like an RF person, like Sharia or Jeff or, all these people, and they're like, well, let's just look at Maxwell's equations. And I throw up my hands like, whoa, wait a second, buddy. I don't get out of bed and say I'm going to do Maxwell's equations today. And like, they're totally right. And physics I'm just assuming holds, because I don't know. I don't want to go look at it. And physics is a thing. I believe that, but not a thing for me. So
yep,
magic, blah blah blah. It's fine for me.
I watched a video from former guest Kathy last time, who does the Kathy Loves Physics thing, and she's talking about her upcoming videos. One of them is going to be like a really simplistic explainer of Maxwell's. She tells you how Maxwell's equations, and she actually takes Derek from Veritasium to task on his, the famous big argument everyone's had about does electricity flow in the wire outside and energy flow.
Oh, cool.
Whatever.
Yeah, I was thinking recently, we should dredge that up again. I really
we should dredge that one
time.
up. Well, she is going to dredge that one up again. And she thinks that if you look at the history of it, and she goes back into the history of Maxwell's equations.
A great angle.
And actually, it sounds fascinating.
Yeah, great angle. But
anyway. Anyway, I think she has a new simplistic way of trying to explain it. So that's what I'm.
That's part. So, anyway, I love Kathy's videos. That part's great.
Yeah. It's anyway.
Yeah.
Anyway, that should be fun. They're in upcoming videos, so definitely subscribe to Kathy's channel.
Yes, definitely.
If you haven't. Our amp hour's well and truly up, dude.
Is it? No, we started like 5 minutes. I know your recorder says
it's 10 minutes past the hour. It's 10 past the hour.
No, my recorder says an hour and 5 minutes, but...
Well, then we're over.
Oh, maybe. Maybe you're right. Oh, maybe you're right. Actually, I maybe started that when we actually started talking. You're right. Okay.
All right.
Yeah, okay. Yeah. It's up. I'll let you go. I'll just let you go. I can let you go.
Fine.
All right. Get out of here.
Catch you next time.